A few years ago, I made a video exploring some rainforests in unexpected places, and at the end of it, I looked at this precipitation map for my own home state of New York, where we identified two areas, one within the Adirondack Mountains and the other in the Catskill Mountains, that both receive upwards of 55 inches of rainfall per year, which just so happened to be our lowest threshold for rainforest. Naturally, this raised the question of whether or not either of these mountain ranges could be topped with lush, temperate rainforests. Though at the time, I didn't feel like I had enough information to say one way or the other, so I simply ended that video by suggesting, and I might actually have to go out and visit these remote woods here in the middle of New York and decide for myself whether or not I think they deserve the title of rainforest. And I'll be honest, I kind of forgot about this idea for a while. That is, until I received a message from one of you all, my viewers, named Dave, who just so happened to be the executive director of the Michael Kudish Natural History Preserve in Stamford, New York. He went on to explain how our preserve is named after Michael Kudish, who is a retired professor of forestry at Paul Smith's College. His lifelong work of 51 years is to recreate the forest history of the Catskills since the end of the last ice age. I would love for you to meet him and would also like to invite you to our preserve. And this piqued my interest for two reasons, really. First, because if you look him up, you'll find Michael Kudish is a man who has dedicated his life to the study of these exact woods, starting with his dissertation on the history of the Catskill Forest, and has spent every year since trying to understand what factors influence the makeup of this forest.
That's what I do. I look at a forest and try to reconstruct its history.
Which, if you ask me, sounds like just the person who will have answers to all of my questions. The second reason this interested me is because the longer I work making YouTube videos about all the amazing places this world has to offer, the more I want to see some of these sites for myself. Ideally, this channel eventually allows me to travel and study the world up close. But before I get carried away, I need to practice the basics. Skills like interviewing knowledgeable people, flying a drone, and filming my own B-roll that'll hopefully open even more doors for me later on. And so, altogether, this invitation represents an exciting opportunity, both for me to answer some questions I've posed in previous videos, as well as to continue to push my own video making abilities. So please join me as I trek back into the rugged upstate New York wilderness to see if I can find any more rainforests in unexpected places. Okay, hang on. Before we head out to the preserve, I feel like real quick we need to review the main lesson from the first video. If you'll remember, what we ended up learning is that the term rainforest is near impossible to actually define, as forests exist across a spectrum of moisture conditions, and so where exactly we draw the line between what is a forest and what is a rainforest will always be arbitrary. In reality, there's just forest and even richer forest. And okay, sure, I'm pretty proud of myself for reaching such a nuanced understanding, but this is also pretty antithetical to our new goal of defining an area as a rainforest or not. How can I simultaneously claim rainforests don't exist while also trying to prove an area as exactly that? And, well, my answer to this conundrum is to use somebody else's definition. In this case, Paul Alabax, who wrote the definitive paper on this subject, titled The Comparative Ecology of Temperate Rainforests Across the Americas, way back in 1991. One of the stated goals of this paper was to come up with a scientific definition for temperate rainforest, which a little further down we'll find consists of 4 criteria. To start, the area must receive at least 1,400 millimeters of rain per year, or roughly 55 inches. And this makes perfect sense to have as a first criteria, right? After all, in the previous video, we used this world precipitation map to determine the lowest bound for potential rainforests, which corresponded to this pinkish color, as it is what defines the outer edges of the Amazon, Congo, and Southeast Asian rainforests. looking to the key of this map, we'll find this color also just so happens to represent 1400 millimeters, which means not only were we pretty spot on in the last video, but also that this first criteria is more than just an arbitrary number, as we too have independently recognized it as being significant. But okay, that was only the first of 4 criteria. So what else is required to qualify a forest as satisfyingly wet? I mean, shouldn't rain be all that's needed to make a rainforest? Well, if we look next, temperate rainforests must also have cool, frequently overcast summers, with July temperatures averaging only 16 degrees Celsius, or 60 degrees Fahrenheit. And I don't know about you, but initially this criteria seemed a little strange to me, as what difference does it make if this place is 60 degrees or 106 degrees? After some more thought though, I realized it all goes back to the fact that temperature and precipitation are directly related. As we should all know by now, temperate rainforests can really only be sustained by a phenomenon known as the orographic effect, where mountains force warm, wet air upwards, causing it to cool down, reducing its capacity to hold moisture, leading to excess water precipitating out of the air and onto the surface as rain. Like this, we can see how the greatest rainfall will always correspond to wherever it's coldest, because that's literally what causes the rain to fall, explaining why temperate rainforests must be cooler than their surroundings. After that, wildfires must be infrequent to the point where they are no longer an important evolutionary factor. And this criteria actually makes a lot of sense too. If a forest truly is rainy, then it should be too wet to normally catch fire, whereas any forest in which fires do regularly occur must be prone to drying out, and thus cannot be considered rainforest. And the best way to test for this is to look for the prevalence of fire-adapted species. Lastly, temperate rainforests must experience a dormant season caused by low temperatures. And to tell the truth, this criteria doesn't really come into play here, as all it's really saying is that temperate rainforests will only occur within temperate climates, where winters are freezing cold and many of the trees lose their leaves. Which, as somebody who lives in this region can tell you, absolutely happens here, and so we don't even need to leave the house to know that this criteria is already satisfied. As far as I can tell, the only real purpose in including this final criteria was more so to help differentiate temperate rainforest from tropical rainforest, which of course do not experience severe winter weather. So that's all we're looking for then? 1400 millimeters of rain, cool overcast summers, no forest fires, and cold winters? Is that really all it takes to make a rainforest? Well, I for one can't say I was satisfied with that definition, as it makes no consideration whatsoever regarding the character of the forest, including its canopy structure, its species richness, or even just the relative abundance of life, which if you ask me are all equally important aspects of rainforests, as it's kinda their biological productivity that makes them fascinating to study in the first place. And so, if I am to believe there is a rainforest here, then I need to see some quantifiable change in its ecology that reflects that. While there are a number of ways we can do this, the metric I'm going to use will be the forest's structure. What I mean by this is that the forests around where I live tend to be organized into a forest floor covered in plants and tall trees that form a single canopy. This is the basic structure of forests pretty much everywhere. The added moisture of rainforests, however, allow them to support a secondary layer of foliage, the understory. And this, I believe, is truly what distinguishes rainforests from regular old forests, as it's the understory that provides additional resources like food and habitats that can in turn support even richer animal communities. And so if I'm to be convinced of a rainforest, I'm going to need to see a substantial understory, as they both signify the heightened moisture the area receives, as well as indicate that that added moisture is actually affecting the forest ecology in a productive way. Exactly what kinds of plants we find in the understory doesn't really matter. But if we look further south to the Great Smoky Mountains, the only truly confirmed temperate rainforest on this side of the continent, for an example, we'll find it's mostly rhododendrons that filled this role, as we can see them occupying nearly all the space between the floor and the canopy, creating multiple levels of vegetation. So that's more or less what I'll be looking for, if the Catskills satisfy all the criteria, and if doing so truly changes the character of the forest. Funnily enough, this paper ends by posing a similar question. What is the relative importance of biogeographical factors and the physical environment in regulating the evolution of forest ecosystem structure and function? And with these questions and criteria in mind, I think we're ready to head out to the preserve. On the drive up, the landscape was drenched in fog, a fairly common yet nonetheless spectacular sight to see here, and one that really got me in the mindset that I could potentially be venturing into a rainforest today. When we finally arrived, the first thing Mike wanted to do was show me all the data he's been collecting for the past decade.
I filled up my car with all my stuff to show you, because probably 95% of it you have no interest in, but there might be 5% that you might.
I wouldn't speak so soon.
Well, I'll pull these 3 boxes out and, wait a minute. Okay, this is the collection of preserved maps, the large rolled up maps. Each map has a different subject. So there's a geological map, there's a soils map, there's a topographic map, there's a vegetation map, there's a human history map. These are the preserved files, the field notes. Here's the listing. 700s are the flora, 710s are geology, 720s are soils, 730 stone piles, 740 local human history, 750s large rolled survey maps, that's that. 760s is fauna, 770s is fungi. So those are the subject headings.
Which was great because it allowed me to immediately start addressing our first criteria: how much rain truly falls in the Catskills.
This box says Catskills climate, because you had some questions on precipitation. So we have Jerome Thaler's weather book, climatic data, Monk Trust data, Catskills precipitation. These are my records. I started keeping records about 2008. I have a rain gauge. I haven't filled in past, oh my gosh, I haven't filled this master chart in since 2021. Well, I have all the data home. I have to fill it in. This is rain and snowfall data going back 2008 at my house.
And that's the totals on the bottom, the annual?
Yeah.
Wow.
The black is rain and the red is snow. But I haven't filled it in 2 years.
Do you have precipitation maps of the area?
Yes, this. Now I brought this. I knew I had it. David might want to see this. He likes my old cartoons. Look at the date on this one. Well, this is part of my thesis.
Wow.
So we have mean annual precipitation. This is from National Weather Service data, because I had to see all these green dots.
Yeah.
Those were all the recording stations at that time. Most of them have closed since. There were other people collecting data. So above 60 inches is orange, 50 to 60 is yellow, below 40 is brown. This is the highest. Slide Mountain Station is at Wintersick Lodge. It's the highest recording station precipitation in the state. It's about 60 inches a year, rain plus melted snow. Hunter Mountain has quite a bit.
This map confirms for us that there are in fact areas within these mountains that receive rainforest degrees of water, with the 2 tallest peaks in the range, Slide Mountain and nearby Hunter Mountain, getting hit with over 60 inches or more than 1,500 millimeters of precipitation annually, which certainly satisfies our first criteria. And so then the next thing I needed to determine was whether or not this area experiences cool, overcast summers. And to tell the truth, I didn't really need Mike's help figuring this one out, as all it took was a look up to see just that: gray overcast skies, a regular occurrence in these mountains, even in July when I was visiting.
And as far as temperature and cool summers, as soon as the sun goes down, it's chilly. You have to put on a coat in the summer. We say that there's 1 week in August when we don't have to wear fleece.
But if you don't want to take my or Dave's word for it, we can also look at a map like this, which shows us the average temperatures across the state. We can see these southern coastal areas are much warmer than the upstate interior, while the Adirondack Mountains are discernibly colder than everywhere else. And in the middle of it all, we'll again find the Catskills acting as another, smaller island of cooler than average temperatures. If you ask me, this map only reinforces what we already know, that this is a mostly cold and rainy place, one that I believe satisfies our second criteria. In order to satisfy this specific number, 16 degrees Celsius, I turned to Jerome Thaler's Catskill Weather Book, where we'll find a map of summer temperatures, and unsurprisingly, Slide Mountain is the coldest point anywhere in the range, at 60.2 degrees Fahrenheit. Technically, 16 degrees Celsius equals 60.8 degrees Fahrenheit, so we can in fact say at least the very highest parts of these mountains do remain below this temperature threshold. So then next, I needed to address the question of wildfires. For this, Mike took out another one of his maps.
Mike mentioned earlier his burn
Index
theory.
It was a black and white map. That was the map, the first map I did. It's about 2009, 2010, because the burn index occurred to me in 2009 up on Morris Hill.
So rather than looking for species that are burn resistant, he maps the species that are there because of a burn. If there's 2 species, it's a low burn index. If there's 11 of those species, you know there was forest fires there.
To make this a little easier to see, let's give this map some color. The darker the red, the greater the concentration of fire-resilient species. And by mapping the concentrations of these species across the whole region, Mike uncovered another interesting pattern. For the most part, the Catskills lack fire-resilient species, and rather it's where the Catskills end and the Hudson Valley and Delaware Valley begin where fire resilience becomes greatest. Meanwhile, the peaks of Hunter and Slide Mountain host almost no burn species, and in fact, here we'll even find an area of forest Mike calls the vast oakless region.
This area in here, gee, I didn't even label it. I don't even know I had invented the term yet. Yes, I did. The vast oakless region. No oaks.
And considering oak trees are the predominant fire-resilient species here, their absence across this tract of land suggests wildfires rarely, if ever, affect the area. Because this oakless forest roughly corresponds to the wettest portions of Slide Mountain, my initial assumption was that it was the rainfall that was keeping the forest wet enough to prevent fires. But clearly that isn't the full story, as we can see other parts of the Catskills where 8 or more burn species are concentrated within a single area, exposing the fact that fires have historically occurred in some parts of these mountains. These hotspots, however, don't appear to follow elevation, rainfall, or temperature patterns, forcing us to ask if it's not rain that determines where fires in the Catskills burn, then what does?
The higher the number, the more likely the Native Americans were burning. And Native American people have told me that, and scholars who study Native American people. To the north and west, you had the Iroquois Confederacy, the Akwesasne people, and to the south and east, you had the Algonquin-speaking people, the Lenni Lenape, and the Minisink, and all the different Algonquin-speaking tribes. And they're burning primarily for food, indirectly and directly.
It turns out the greatest influence on the distribution of burn species here isn't the climate at all, but rather the human history of the land. Whether it was the Iroquois or Algonquin, the people who lived around here all practiced agriculture in pretty much the same way, by starting fires and allowing them to clear swaths of land. They would then farm these lands until the forest regrew, at which point they'd burn it down again, and again, and again, until the only trees that grew back were those that were most resilient to fire. Eventually, the forest surrounding Native American settlements evolved to be composed almost entirely of fire-resilient species, making it much harder to clear. And once this happened, the native people would simply move on to a new patch of forest and begin the burning cycle all over again.
So you can tell where the Native Americans have been, and you can tell to what degree they were burning the forest by the burn index.
In this way, fire-resilient species followed wherever the native people went. And so what a map like this can actually show us is the historic distribution of Native American populations. This is why we find the highest burn index here in the Hudson Valley, where populations were greatest. Meanwhile, the western side of the mountains were much less populated, with the exception of the Delaware River, which explains these two hotspots.
And if you ask, does it correlate with where the villages were? Yes, it does. This is Pocatacon, and this is Pepacton.
And so the reason we don't find as many burn species on the summits is simply because they're not really ideal places to live, and the people preferred to stay by the riverbanks.
It's just the Native Americans were not in there in any numbers. I mean, they might have passed through on hunting and fishing parties, and gathering, scavenging, but they never settled there, they never burned there.
Like this, we can see that fire resilience was never naturally selected for in the Catskills forest, but rather is a more recent development courtesy of us humans. And even then, there remain large areas of untouched woods where fires have never spread. Because of this, even though there are still some fire-resilient species here, I'm willing to say fire doesn't play or no longer plays an important evolutionary factor across most of the Catskills, meaning all 4 of Alabak's criteria for temperate rainforest have now been satisfied. And so at least on paper, the potential for temperate rainforest does exist here in the Catskills. But that's the problem with using definitions like this, as all it took was a couple of maps to convince us we understand a place we've never been to. And if these 4 criteria were all we based our conclusions on, then we would have made up our minds without ever even having set foot in the actual forest. And that's why I came up with my final criteria, as it demands we enter these woods and take what we find living there into account.
All right, into the thick of it.
Before we could though, first we needed to pass through a dense fern glade, which proved to be an obstacle in its own right, as just beneath the surface vegetation lied what you'd call a seep, a place where water gushes out from the ground.
Wait a minute. Wait, I'm stuck. Which way did you go? I'm kind of stuck here. Wait a second.
Go this way. Other way.
To the right? Well, I'm stuck this way too. Phew, I got a mouthful of spirea. I can't see where I'm putting my feet. Squish. How'd you get down there so fast? Which way did you go? I can't even...
Oh no!
Wait, I'm stuck here. Wait a second.
Multiflora rose in here.
Well, don't push through that.
I gotta come back here with some clippers. Look out, this is the multiflora. It hurts a
Meadow
lot.
sweet at least. What you got?
Ow.
Where my
touch
pole
this
is
guy.
stuck. My pole is stuck. There it is.
Along the way, Dave spotted an awesome butterfly, but I failed to capture it on video.
That's a nice butterfly.
Was it black?
It was like so cool looking.
It was cool looking.
Though using Mike's description of it being black mixed with my own memory of it having like bright blue and orange spots only on the bottom of its wings, once I got back here, you just know I had to bust out my field guide for the butterflies of North America. And after some searching, I was able to find this, the white admiral, which looks pretty similar to what I saw, except I don't remember it having these huge white streaks, and instead its wings were entirely black. So I kept reading and learned there are 2 distinct populations of this species. The more northern white admiral, which live across the boreal forests of Canada, and then any further south you'll find the red-spotted purple, which looks like this. Understandably, these were originally thought to be completely separate species, but close observations showed that where these ranges overlap, white admirals and red-spotted purples can mate and produce viable offspring, which look like this. And this, I'm pretty sure, is what we saw out there. While the white admiral is noted as being quite a common butterfly overall, I couldn't help but feel like the presence of an integrated white admiral was the perfect showcase of how the area's geography directly affects and actually benefits its biology. You see, this position within the narrow transition zone between boreal and temperate forests means that this area has the potential to receive species from both biomes, allowing it to host a greater biodiversity than either forest would individually. Because of this, I think it's safe to say the biogeography of the area is not going to be what limits the richness of this forest. After this, we carried on past the seep until we came across a small stream, where I got my first real taste of the forest.
I've hiked a lot of mountains with Mike over the past 20 years, and I'm telling you, this is the wettest one.
Here, the floor was rich with mosses and ferns, but maybe more importantly, there were plenty of shrubs like this that occupied the space between the floor and the canopy. Many of these shrubs even offer berries, which I think serves as a good demonstration of the additional resources understories can contribute to the environment, even if Dave says this species happens to be non-native. Next, we found some basswood trees absolutely riddled with holes, evidence of woodpeckers being present here. Underneath every rock, underneath most of the rocks, underneath some of the rocks you can find salamanders, which tells you water was never too far away. Overall, the abundance of life we found along the banks of this stream was again a promising sign that this forest contained all the ingredients necessary to support a richer flora and fauna.
I don't even see it. If it moved, I'd see it.
He's right there.
Oh, still don't see it. How'd you ever spot that
He
thing?
jumped.
I still don't see it. It's camouflaged. Where is it?
It's right on that stick, between those two blades of sedge or whatever it is.
Well, I don't see it.
But of course, the stream provides additional water, and the real test will be to see if the forest can maintain this level of vegetation beyond its banks. So we finally crossed it and continued deeper in. Almost immediately, you could just feel that abundance of life diminishing, and pretty soon the forest opened back up into a floor and a canopy. But then we finally started climbing up the mountain, meaning this is the point things should have started getting colder and wetter.
All right, so now we're gonna start climbing.
Oh yeah, look how steep it is here.
We climbed until we reached an important milestone on the preserve, what Mike and Dave called the upper pasture limit.
Well, isn't this where the upper pasture limit trail comes in?
Yeah, it's right there. There's a red mark.
Okay.
So this is the upper pasture limit, and this is one of the first big sugar maples.
Well, the trail is built right along the boundary. If you look up, you're on a forest that's never been cleared. You look down, it's a forest that has been cleared.
And you can see other big trees. You didn't see a lot of big trees down there, but if you look in here, you'll see other big trees, but we're gonna get to the really big ones.
To understand the significance of this, you need to know that all this land was cleared and converted to pasture just a few hundred years ago when European settlers arrived.
Probably when it was cleared, 1820, 1815, all that original forest would have been destroyed.
What this means is that everything we've seen so far is only what has regrown over the past 100 years or so, making this an incredibly young forest, one that has not had enough time to mature back into a climax ecosystem. However, just like the Native Americans, the European settlers typically left the peaks of these hills intact, as they simply weren't worth the effort to clear. And so by crossing over the upper pasture limit, we entered into a sample of forest that has remained untouched by humans for thousands of years, providing us with our first glimpse into some truly pristine Catskill forest. This is where we found the biggest trees in the whole preserve, some, by the looks of it, many centuries old, a good indicator that this area has never been cleared. And it was finally after hiking through this part of the preserve for some time that I felt like I was ready to call it. Despite everything it has going for it, even the richest area of this forest struggles to maintain an understory, and the vast majority of it looks like this.
I'm ready for my afternoon nap. Excuse me.
What this tells us is that this is definitely not a temperate rainforest. But you don't just have to take my word for it. After spending the last half-century exploring these mountains, this is the same conclusion Mike came to.
This is really not a unique area. One thing that maybe sets it apart from other areas of abandoned farms and non-farms is the abundance of wet areas and seeps and watercourses and brooks like this, so that it makes it for a very, very diverse flora. But other than that, you have plenty of old farms in the Catskills, hundreds of them, and especially the western part, which would be something similar to this.
In fact, by the end of the hike, Mike asked us,
would our guests be disappointed if we told them that the vegetation and history of this preserve is very commonplace, very typical for much of the western Catskills? The vegetation here is not saying anything unusual.
And I thought it was funny that Mike was initially hesitant to reveal just how unspectacular of a forest this truly is, as that was actually exactly what I was hoping to find. You see, despite technically being within the Catskills, the Michael Kudish Natural History Preserve is on its periphery and actually falls outside of the area of greatest rainfall. I knew this wasn't going to be a rainforest before I even left. It couldn't be. So then why did I bother making a trip there, you must be wondering? Well, now that I feel like I've seen a sample of Catskill Forest at its richest, I can use what I've seen as a control and compare this to the conditions found at the summit of Slide Mountain, where rainfall reaches its maximum, and see if there's any difference. I made this trip alone because I already knew this area had the potential to be rainforest. All I was looking for was evidence that it was. Arriving at the trailhead, the first thing I did was take a good look at the forest I found here. While it certainly was rich, there still wasn't much of an understory here, and it felt very similar to what we found with Michael Kudish. Of course, I was still only at the base of the mountain, and the higher I climbed, the rainier it should become. So I set off onto the trail, and I climbed, and I climbed, and I climbed. Every so often, I stopped and checked on the forest to see if I could notice any changes taking place as I gained elevation. Sure enough, I sorta did. I started finding more berries along the side of the trail, more mosses clinging to the trunks of trees, and I continued to find more streams crossing over the path. It was pretty clear that as I climbed further, this mountain was getting richer and richer with vegetation. However, peering beyond the trail to the real forest, I still couldn't make out much of an understory, and more often than not, the canopy formed the only discernible layer of foliage. Even these berries grew close to the forest floor and couldn't quite be considered additional resources of the understory, so I continued climbing and climbing and climbing until I did begin to notice a true change occurring in the forest's ecology. At a certain point with each step, it seemed there were fewer and fewer leafy deciduous trees and more needly coniferous trees. Before I knew it, the entire composition of the forest had gone from one dominated by sugar maples to one of balsam firs. Or in other words, the temperate forest was transitioning into boreal forest.
If you have balsam fir dominated forest, like Slide Mountain, that's more or less considered boreal forest, not temperate.
And at first glance, it might seem like this change could be due to the increased rainfall around the summit. But I made sure to ask Mike about this, and he assured me that,
but the fir is there not because of the precipitation. Balsam fir can tolerate much less precipitation per year, and it can take droughts quite well. The reason why balsam fir is on top of Slide is because the northern hardwoods forest has not been able to conquer that mountain in 15,000 years. And the balsam fir, which was there first, has been able to maintain itself because of a lack of competition. If those conditions were good enough to support a northern hardwood, sugar maple, beech, or hemlock forest, the fir would have been outcompeted thousands of years ago, as it has in many other places in the Catskills.
the balsam fir's presence is not the result of rain, but time, as thousands of years ago when it was much colder, the boreal biome extended much further south, and this whole mountain range was covered in coniferous forest. But in the time since then, the planet has warmed considerably, allowing the southern, more temperate forests to push in, to the point where today the only parts of these ancient conifer forests that remain cling to the peaks of mountains such as this, forming what are essentially boreal islands slowly sinking beneath the rising tide of temperate forests. And if you ask me, this is another perfect illustration of the fact that the Catskills lie within a transitional zone between two biomes. Though what this means is that the presence of balsam fir atop Slide Mountain has nothing to do with rainfall, so I continued hiking until I reached the summit, presumably one of the rainiest places in all of New York State. Here, I kinda went off trail a little, searching for some semblance of an understory, but no matter how hard I tried, I couldn't find much more than this. And if anything, the forest here appeared less rich than some of the mixed forest further down. Perhaps the only piece of solid evidence to the contrary I found was this hanging moss that clung to the branches of many of the trees at the summit. Without a proper root system, or even just contact with a wet surface, this type of moss must receive all of its moisture straight from the air. And so the fact that we find it growing here is a very clear indication that there is an abundance of water here. However, the presence of just one type of moss is not enough to qualify this as a rainforest. And so it was at this point that I finally felt confident in saying there is no rainforest atop Slide Mountain. There aren't any rainforests in the Catskills, and there are no rainforests anywhere in New York State. Now, I understand this is a bit of an anticlimactic conclusion to come to, but at the same time, this is exactly what I was hoping to find. First, because it only reiterates the lesson that rainforests as a concept are incredibly difficult to define, as even the most scientifically accepted definitions still fail to take important aspects of the forest into account. And second, because now we're forced to ask why. Why don't the Catskills support a rainforest even though they receive all the rain necessary? What gives? That's the real mystery I was hoping Michael Kudish could solve for me. So finally, I asked him point blank what his thoughts were on this.
I don't know if studies like that have been done on the Catskills. I've never really thought of it as a temperate rainforest, but there are certainly places in the Catskills that get at least 55 inches a year. The problem is water retention in the soil. If you look at Slide, the bedrock's within this much of the surface. The glacial till is very, very shallow, and the texture is very stony and rocky. There's very little silt and clay to hold the water. So although it gets a lot of precipitation, the soils dry out very quickly. And if you go a few days without rain up there, those trees will be water stressed, and the hemlock can take it. Sugar maple could never take it. In other words, these trees can take the short growing season. But my studies of a lot of the trees around here suggest that the problem is not enough water. And it's not a precipitation problem, it's a soil water holding problem.
And just like that, it finally makes sense. It's not about rainfall, it's about water availability, and I was naive enough to equate the two. Luckily, Mike was here to point out that there's another part of this equation, and that's runoff. So say an area like this receives 60 inches of rain annually, but maybe 15% of that is lost before it can be properly absorbed. Then it's effectively only receiving 48 inches, well below our criteria for rainforest. Whereas an area receiving less rain, like 58 inches, but only loses 5% of its water to runoff, can still come out above that threshold.
The climate really, from one part of the Catskills to the other, really affects the vegetation very little. I won't say none, but really insignificant. What really is important is water retention, water holding capacity of the soil. That is extremely important.
Like this, we can see that the water retention of the soil is equally as important as rainfall in determining an area's overall water availability. Though now I can't help but wonder, why is this the case? Why do these soils retain less water? Well, you might remember Mike saying this was because most of the soils up here are rocky and lack any clay or silt, meaning they physically can't hold on to too much water. And sure, this is part of the answer, but it's still not getting at why we find rocky soils here to begin with. Ultimately, whatever causes this can be seen as the root cause behind this forest's underwhelming stature. And the only way to explain an area's inherent geology is through its natural history. In the case of the Catskills, we need to go back 20,000 years to the height of the most recent ice age. During this time, the entire mountain range sat beneath a heavy blanket of ice that scraped away any and all loose soil, eroding them down to their very bedrock. Then, as the glaciers began to recede some 15,000 years ago, in their wake they deposited a layer of what's called glacial till, or basically all the loose rocks and boulders the ice had picked up along the way. And so, once the Catskills had finally become ice-free, all that was left of them was a few barren hills covered in a thin layer of gravel. It would be from this state that gradually plants and eventually trees would start to grow and build up the soils, but at a rate of just an inch per 1,000 years, only about a foot or two of topsoil has accumulated here over the 15,000 years since the ice melted, resulting in a shallow, rocky soil with low water holding capacity, which ultimately limits plant growth. But what about the hanging moss, you must be wondering? It tells us that there's plenty of water here. Well, the only reason this moss is able to grow here is because, like I said, it doesn't have roots. It receives its water directly through the air, and as we've already determined, there's plenty of moisture in the air. It's the soils where the water is lacking. Or in other words, this moss only grows here precisely because it has zero interaction with the soil, and thus is not limited by its poor moisture holding capacity, and ultimately serves as the perfect proof that rainforest conditions do persist here, yet the environment nonetheless remains limited. So, to return to the final question posed by this paper, what was the relative importance of biogeographical factors versus the physical environment in regulating the evolution of the forest ecosystem? Well, based on everything we learned today, I'm willing to say neither biology nor geography acts as the limiting factor here, but rather the ecology is restrained entirely as a result of the physical environment, the underlying geology upon which the forest sits. And to tell the truth, I like this answer very much, not only because it takes into account every aspect of natural science I try to focus on, but also because now we can apply what we've learned to our original goal of finding rainforests in unexpected places. We can do this by looking at another rainfall map, this one for the entire Appalachian region. If we then overlay the furthest extent of ice during the last glacial maximum, then we should theoretically have defined the northernmost possible bound for temperate rainforest in this region. Doing this, we can see how mountain ranges like the Catskills, the Adirondacks, or the many peaks of New England have all been glaciated too recently to support rainforest, despite their excessive rainfall. Any further south, however, and all these mountains managed to avoid recent glaciation, which explains why the Great Smoky Mountains host the only truly recognized temperate rainforest on the East Coast. But if we look just a little closer, we'll find another area within West Virginia that's, albeit smaller than the Great Smokies, but larger than the Catskills, where rainfall exceeds 1,600 millimeters annually. Unsurprisingly, this moisture surrounds the highest peaks of the Allegheny Mountains, supporting the Monongahela Forest, what appears to be yet another patch of incredibly rich woods. Though just like the Catskills, the only way we can know for certain whether or not this actually is the furthest reaches of rainforest on this side of the continent is by going there and getting a first-hand account of the place. So if you enjoyed this video and would like to see me continue searching for rainforests in unexpected places, leave a like. And maybe next year I'll make a trip out to the Monongahela Forest and put this new theory to the test.
Yeah, we just scratched the surface.
Yeah, I'm sure we did. And Dave and I at times would get lost exploring and mapping. That's how vast it is and how difficult it may be to navigate.
And it's a well-kept secret. It's not as if people just come here on their own and explore. Yeah. And we like it like that. So.